Okay, excuse me, Algebra 1, Chapter 7, Section 4. We're going to solve polynomials. We're going to take some of those factored versions of what we saw and actually find solutions. These are, when they have an x squared or a y squared or something like that, these are called quadratics. And we're going to graph them later in the chapter, and their solutions are where they actually cross the x-axis. And so we're going to go ahead and talk about solutions first. So if I were to take this and then what we've been doing is taking those two factors, and we have been doing the FOIL method or distributed property, but instead of doing that, what we're going to do is we're going to actually solve these. And because they hit the x-axis at 0, that tells us that we're going to set each of those factors equal to 0. So what you're going to do is create a t-chart and separate the factors. Take the first one, no parentheses needed anymore, and we're going to set it equal to 0. It's going to cross the x-axis at 0. And then we're going to take the second one and also do the same thing. Set it equal to 0. And then these are just multi-step equations that we did back in the beginning of the year. And so we're going to solve for x. So in this first one, I'm going to add 6 to both sides and get 2x equals 6. And then I'm going to finish that by dividing by 2. And so x equals 3. The second one, I'm going to subtract 2. And so now I get 4x equals -2. And then divide both sides by 4. Again, not using the calculator on this one to get a decimal, but just reducing that fraction. What that tells me is if I were to graph this, and again we'll get to that later in the chapter, it's going to cross the x-axis at 3, and it's also going to cross the x-axis at -1/2. Now what these are called parabolas, and so let's see if I can, we'll be able to access that. So a parabola, I'm going to come over here, is just, there we go, it's just something that looks like that. Now let's see if I can get that to work for me. Maybe not. Well, and it would also be this way as well. What I'm trying to do is get the lines on the end of those, but it's not working. There we go for that one. Maybe back up here. There's that one. Come over here. Well, it just doesn't want to cooperate with me, so that's okay. So those are going to be, basically kind of looks like a U or an N. So it's going to come down across the x-axis, it's going to turn and come back up, or it's going to come up and then go back down. Get to that later. So I also might have something that looks like this. Let's take it a little bit further. Oh, nope. Sorry. That makes it not quadratic. There we go. So I have something like this. I have to notice that I have two separate factors here, and what I want you to do is take the one on the outside and put it in parentheses. And then when you set out your t-chart, you take the first one, which is just x, set it equal to 0. You're already solved there, it's already done. And then you have x minus 9 equals 0. So you would add 9 to both sides, and x would equal 9. So this one would cross basically at the origin, and then it would cross 9 spaces to the right. Okay, so again, just taking those two factors and setting them equal to 0. Now, there might be some that have more than two factors. Maybe you have something like this. Oh, what do we got? Maybe, and then maybe you throw a number in there. Okay, so now I do a little bit more than a t-chart. Okay, this one's kind of going to look like pi, and I take each of those and I set them equal to 0. Now what you're going to see in the last one is something a little crazy, kind of doesn't make sense. Obviously 9 does not equal 0, so that won't be a legitimate factor. We're just going to throw that one out. And then with these, we're going to add 2. Oh, don't know why I put a second line in there. And then we're going to subtract 2. And that's how we find the factors if they're given to us. Now, we are going to begin factoring just a little bit. We're going to factor with binomials. So what if I had something like this? I had 2x squared minus 3x. And I want to make this is a binomial, so I want to make this into something that looks like distributive property. So I want to look at both of those, and I want to see what they have in common. You'll notice that they both have an x. So I could take that x to the outside and then create a distributive property problem and ask myself, x times what value is going to give me 2x squared? And that's going to be 2x. Bring down my minus sign, ask myself the same question, but ask x times what gives me negative 3x. And in that case, that would be negative 3. So this is the factored version of this. And I can check it by doing distributive property. X times 2x is 2x squared, and x times negative 3 gives me negative 3x. So that's a case where they just have a variable in common. However, they could also have what did I just do? I'm sorry, that should meant to be a y. Okay, so now I look at that negative 16 and negative 8, and I know that negative 8 goes into both of them. So I'm going to pull out a negative 8 as well. And I see I have a y to the 4th and a y squared, so this time they don't necessarily just have y in common, but they also have y squared in common. So I'm going to take out the biggest number they have in common, and that would be 2. Some of you might be saying, well, the biggest number is to the 4th power, but that y squared doesn't go to the 4th power, so I can't go that far. So now ask yourself, negative 8y squared times what is 16y to the 4th? Excuse me, negative 16y to the 4th. And so that's going to be 2y squared. And then negative 8y squared times what is negative 8y squared? And that's actually a positive 1. Now, some of you will wonder why this isn't the same sign as that. That's because the negative out in front changed that. So if I did distributive property, I would say negative 8y squared times 2y squared is negative 16y to the 4th, and that's what I wanted. And negative 8y squared times 1 is going to be itself, which is negative 8y squared, which is also what I wanted. And so that would be the factored version of that. So just a little reverse distributive property. And that's Chapter 7, Section 4, Solving Polynomials.